Okay, Assalamualaikum and good evening. My name is Muhammad Ali bin Muhammad Ayub. Today I will show you how to program timer and interrupt by using 8051 microcontroller. Okay, this is for example the timer and interrupt for the introduction and the result. Okay, for the introduction, microcontroller application require the counting of external events such as frequency of a fast train or the duration of precise internal time delay between computer action. Both of these tasks can be accomplished using software technique, but software loops for counting or timing keep the processor occupied so that other, perhaps more important functions are not done. To relieve the processor of this burden, two 16-bit counter named T0 and T1 are provided for the general use of the programmer. Each counter may be programmed to count internal clock paths acting as a timer or programmed to count external paths as a counter. For the interrupt is the first branch in the sequence of a program in response to a hardware or software initiate signal which may occur at any time that the system is in operation. It causes the process to suspend its present task and transfer control to a new program called the interrupt service routine, which is ISR. The program that the processor executes in responding to the interrupt is called the interrupt service routine, ISR. This ISR is executed in response to the interrupt and must satisfy certain specific requirements of both of the interrupting peripheral and the interrupt system of the microprocessor. Okay, for the first task, we must write a program to generate square wave at T1.5 using timer 0 mode 1. Use the following value for TH0 and TL0. For the TH0, the hexa value is 0FF and 0F2. For the T-low, 0FF. For the T-high and 00 for the T-low. By using this value, calculate the time of half period of the waveform and measure the output using the virtual oscilloscope and measure the output on the actual T1.5. Okay, for the first hexa value TH0, 0FF and 0F2, this is the program and this is the example at the produce and this is the example of the wave. Okay, I will show you how this operates. Okay, for the first task, we must use the TL0 and TH0 is equal to FF and F2. 0 F2, we change to the value F2 0 F2 FF. Okay, this is the example of program. Okay, first we set ST mode equal to 01 timer 0 mode 1. Here we put move A to 00H, move TL0 0F2H, TH0 0FF, and we put a complement as a toggle T1.5. We call the delay SJump here. We put a delay again and set B TR0, which means start timer 0. Again, J and B F out TF0 again. We clear the TR0, clear TF0, return and end. So we can try. I will show you how the wave produce. We must use the oscilloscope, and because it generates 1 bit, we use 1 LED for the task A. We run. The LED will on and this wave can produce. Okay, we stop, and from this point, at, at this point, we can get the half period, which is 28.02 microsecond. Okay, for the task B, we change the value of TL0 and TH0 to 0FF and 00. We create hexa file and run again with the same program. Now I show you the output waveform for the new hexa value. Okay, the value is 27.79 microsecond. Okay, for the task 2, by using timer 1 and mode 0, calculate the value of TH0 to achieve a delay 20 milliseconds. Write a program using this value to produce single pass at T1.0. The program must use timer interrupt. Okay, this is the program. But first you must know how to calculate the delay. This is the for example when we use delay 20 milliseconds, and this the example of half wave. For the timer 1 mode 0, we can get the 8192. After that we divide by 5000 microsecond to get 40, which means the value of R7. How we can get the TH and TL? 500 microsecond, we must divide by 1.085 microsecond, and we can get a 460. After that we minus the value 8192 minus 460, we can get the answer in decimal. After that where we change to the hexa value. Okay, this is the example of program for task B. Okay, first we must put a long jump here from the main. For RG 1VH, we set as a timer 1 interrupt vector. Okay, we use toggle T0.1 as a pin complement. After that we call delay RETI, return to interrupt. Okay, the value is 34 and 01 for the TL1 and TH1. Okay, that's it. So we must run at produce. This is the example of simulation. Why we use 8 bit of LED? Because from the question you must use 8 bit. We to how to know the output. Okay. First we load from the hexa task B. Okay. After that we run. Okay. From this oscilloscope, we show you how the output waveform produced. for the 20 millisecond delay. Okay. From this point and this point, we get 150 microseconds. Okay, for the task 3, we use the same program. But we must create delay of 1 minute. First, we must do the calculation for delay 1 minute. We know the timer 1 mode 0, the value of decimal is 8192. 1 minute we convert to millisecond. After that we divide into 50 microsecond. Okay, for the register 7, how we get, because we divide by 255, which means register 1 is equal to 255, so we get 470. After that we divide again to get register 6, because the value of this value is higher than 255, so we divide again to 230 and we get 2. So the new value is we assume as register 5. Okay, to get THNTL is the same method for the another task. Okay, I will show you the program. By using the same program, we just add here move R7, move R6 and move R5 from the calculation. After that, we skip this value. We try to run. So the output is produced, and we stop. We take this point from this point and we get the value, which means 152.50 microsecond.